afternoon. I hope this conference is going great for all of you. How many of you have built and deployed AI agents in production? Can you show off your hands? Okay.
A few.
Developers are building and deploying AI agents everywhere. This is primarily to enable their customer to innovate in the areas of productivity improvement and automation deployment at scale. However, building AI agent for real-life applications and deploying such agents at scale is a complex task. It requires deep understanding of agentic framework and hosting infrastructure. This is Joy Chakraborty, Senior Technical Program Manager from Agentic AI Foundation, AWS, and with me today, Elizabeth Leone from Developer Advocates Gen AI, AWS. Today, we will show you how to build agent using Strands and open source SDK from AWS, and how to make the agent reliable using other AWS services. Today, we will start with first discussing why we need another agentic AI framework such as Strands in first place, how we can use Strands to build agent, how Strands uses tools to accomplish a task, how to build and use MCP tools in Strands. Then we will talk about session and important agentic AI primitives and how to manage it. Finally, we will show you how to make your agent reliable using Amazon S3 Vector. Throughout the talk, we will show you example in code, which you can also follow us by scanning the QR code. We're going to use Kiro, an agentic IDE from AWS, but you can use any IDE of your choice. This being a code walk, we are going to take questions, but I would request to have one question at the end of each section, and then we'll take all the remaining questions at the end. With that, let's kick off these sessions. When we speak to our customer on their journey in building agentic AI application using traditional framework, we observed a consistent pattern in their feedback. Some of the top ones are, we need to write too much of plumbing code to build the most simplest agent, such as a chatbot. How do I know what my agent is doing internally, which makes debugging harder? How do I make my agentic code modular so that I can run unit tests? These pain points led us to design a brand new agentic framework called Strand Agent, which was released early this year, and by now we have 3 million plus downloads. When I think about Strands, it primarily improves developers' productivity by ensuring simple things should be simple to build and deploy. Strand makes your code modular and testable, which is an important aspect as we write application for enterprise customer. Strand follows model-driven design approach, which is key to success in deploying automation at scale. Model-driven design approach allows the LLM to decide the best execution strategies while developer focusing on business problem. This is important because the LLM and the model industry is evolving at a rapid pace. Now, before I show how to build an agent using Strands, let me share at a high level how Strand works internally. At the core, every AI agent has 3 primitives: prompt, tool, model. Here, agent is the orchestrator that executes a task using these primitives as many times as possible. The model is the brain of the agent, which analyzes the request, and it builds an execution strategy. Tools, a library of functions, where each function executes a very specific task, such as, what is the temperature of Las Vegas right now? Finally, the prompt and the context. These are the instructions that the end user and the agent provides to the model to execute a task. Given prompt, tool, and model at high level, in order to execute a task, Strand agents performs these following steps. The model receives prompt and context and documentations about the available tools. Then the model analyzes and decides whether to respond in a natural language, follows a series of steps, or select and use one or more tools. If it decides to use tools, agent is going to run the tools and returns the result back to the model. And these cycles between the model and the agent, also known as an agentic loop, continues until the task is complete. With that, let's build the agent. Now, all the samples for this talk are in Python and Jupyter Notebook. And you can also get them by scanning the QR code. But before I show you the code, let me first show how to set up the environment. So let me switch back to my laptop. So if I go to the GitHub repo for these sessions, and if you go to the README file, you should be able to see the installation instructions. Just follow them. Your environment should be set up, which I have already done for my laptop. Now, please note, each of this notebook has additional samples and bonus content. Just for the interest of time, we are not going to cover all the additional samples, and these are there for you to try it out. With that, let's build a simple agent using Strands with the first notebook. To build a simple agent, such as chatbot, all you need to do is create an instance of an object from the agent class of Strands SDK. And that's it. Your agent should be ready to use. This agent is using default configurations, such as Bedrock Model Provider and Anthropic Sonnet 4 as the default model. Now, since my agent is ready, if I ask this agent, when was the first reinvent happened, it is going to answer me back saying that it happened, let me see. So depending on the throttling that is happening in the model services, sometimes it does take more time to run. If it is going to take too much of the time, what I'm going to do is, just for the interest of time, I'm going to switch back to another copy of it where we did run just before this talk so that we can show the examples as much as we can instead of wasting time. So what I'm going to do is let it run, but I'll show you the. So if it runs, it's going to tell that, yes, the conference happened in 2012. Then, if you'd like to know what my agent is doing internally, you can always inspect the response object from the Strand agents, which is also of type agent results. It provides many useful informations. Some of the top ones are, it gives you all the messages that the agent has processed. It gives you a metrics object, which contains many useful information, such as how many number of times I executed my agentic loop, did I use any tool, the number of tokens it has been used, and many more. So far, this agent is using default configuration. Now, if I would like this agent to use my choice of preferred model and my choice of configuration, what can I do? I can first create a session, which is from the Boto session class, where I can set my AWS configuration, such as the region name or my secret key, and etc. Then I can create an instance of a new model provider where I can set my preferred choice of model, which you can see as I have done. Now, once my model is set, I can update the agent with this new model provider with the new model ID, and then my agent should be ready to use this model, as you can see over here in color red, the answer. Also, so far, this model is using default model provider, which is the Bedrock model provider. But Strand agent does support all other model provider available in the industry. For example, it does support Anthropic model provider, OpenAI model provider, Gemini model provider, and many more. Here's an example where, given I have the Anthropic key, I can create an instance of an Anthropic model provider, and then I can set my choice of Anthropic model, and then I can update my agent to use the Anthropic model. In this case, my agent is going to use the Anthropic model provider instead of the Bedrock model provider. Then, let's look into the system prompt. So far, we have not used the system prompt yet, That's why it's showing none. System prompt can be used to set the persona of an agent. If I want my agent to take the persona of a storyteller for any math problem, once I set that, setting my system prompt, I can then ask my agent to solve a math problem, such as what number comes after 2 in a Fibonacci sequence. When I ask this question, it is not just going to give me the answer, but it will also provide an explanation like someone is telling the story, as you can see in the output here. Finally, Strand agent does support creating specialized agent. For example, if I would like to create an agent who is an expert in providing AWS solutions, I can set the system prompt saying you are an AWS solution architect or expert, and then if I ask this agent, give me a design to build a serverless API, it is going to provide all the services and components and the best practices. If I expand this, as you can see, the best practices to build a serverless API like a real AWS solution expert or architect would provide. With that, let me switch back to the slide deck. Thank you. Agents by themselves have limited capability. It requires tools to overcome the limitation of static language model. Tools enables the model to interact with the real world by accessing up-to-date information to execute a task. For example, the LLM doesn't know what is the current temperature of Las Vegas right now. It requires a weather tool to find the current temperature. Tools can be classified into foundational tool, processing tool, integration tools, and many more. But at the end of the day, tools are just a function to execute a task. For example, reading from a file, writing to a file, accessing memories. Let's see how to use tools in Strand agent. So if I go, and you also can go to the second notebook, you see that I just have a simple Python function called calculator. It performs some basic math operations. Now, if I would like to expose this function as tool, all I need to do is apply a decorator called tool from the Strand SDK, and that's it. My function should be then ready to use this tool. Then what I'm going to do is, while creating my agent, I'm going to set calculator as tools for this particular agent. Then if I ask my agent to, say, perform a multiplication, 156 by 23, it is going to perform these multiplications, but in this case, it's going to use the calculator tool to perform this multiplication. So far, we have seen this agent is using tools which is written in Python code, like the calculator one. However, Strand agent does support pre-built tool. In fact, the Strand agent SDK itself has many pre-built tools which are maintained and contributed by the Strands open source community. So here's an example where I am using a mix of pre-built and tools written in Python code. Specifically, I'm using image reader and file reader. These are the two pre-built tools where image reader is going to read an image, analyze the content, provide me a summary. Similarly, the file reader tool will read a text file such as PDF, analyze the content, provide a summary. The video reader tools, which in this case is a Python code, which is going to read a video file or a video stream, analyze the content scene by scene, and provide a summary to that. Then I can set all these three tools as the tool for this agent in the tool parameter. Then I can set the system prompt saying, you are a multimodal agent, which means you can read and analyze images, documents such as PDF and text file, video files, and provide detailed insights. Now, once my agent is ready, I can ask this agent to analyze this image. In this case, this agent analyzed this image, which is a design diagram of a private chatbot built using AWS services and component. As you can see in the output, The output it's providing is all the list of services, components, data flow that's reflected in the image. Similarly, I can ask the same agent to analyze a document. Let me just go over here. So if I ask this agent to analyze a document, say, for example, this one, which is a README file of the Strand Agent SDK, it is going to analyze this document, and it is going to provide a summary of this content. Similarly, if I ask the same agent, because it's a multimodal agent, to analyze a video file. So let me see if I have the video file. I can actually open it. Just give me a second. I'll show it from here. So this is the video file. So, no, sorry, this is the README. This is the video file. So if I ask the agent to analyze this video file, which basically someone is climbing a glacier in the mountain, it's a 6-minute video, my agent will analyze this video scene by scene and provide the summary of it, which we are going to see in a bit. One point I would like to make over here, that so far, what you have seen, this Strand agent is using tools where model is deciding which tool to use under what circumstances. However, Strand agent does have the capability to make a direct tool use. What does it mean? If you have a use case where you want to make a direct tool call from the agent without involving the model, you can certainly do that in Strand agent just by calling the name of the function and passing the parameters. If you go to the notebook, which is there in the GitHub repo, you should see a sample of that. It's just to call the function and pass the parameters. So that's about tool. Now at this point, what I would like to do is I'd like to take maybe one question if you have anything about the Strand agent and tool so far. Anyone?
No?
Yeah, sure.
Oh, should I?
Yeah, please go ahead. Okay. Please go ahead. We'll take your questions. Don't worry.
I was just curious why you used a tool for that image processing. There could be like just libraries available. You could very well import the library, and because it's just processing it's not connecting to an API or any external service or anything like that, right?
So this is, as I said, the tool is just a function. In this case, this function can be exposed by a library. Make sense?
It's there in the framework. When you install Strands agent, you have a lot of built-in tools inside of the framework that you can invoke every time that you create the agent.
No, I mean, what I'm saying is that why is it a tool? It's just like I can import a library itself, right?
Okay, so let me put it this way. It is a tool from the agent perspective, but so agent by themselves cannot know how to analyze an image. Either if you have a library, you can plug that library inside the agent, or you can use the tool. Now, giving tool to the agent, the model is going to decide dynamically when to use image library or when not to use, when to use some other tools. As you will see in one of the upcoming examples, where we are going to use multiple tools, and the model is going to decide which one to use for the right use case.
You can still create a tool. I'm just saying that in the function, instead of importing it from the Strands framework, I could just get like MATLAB or one of those libraries and use that inside that whenever you put the decorator and the function.
Okay. So if I understand correctly, I will not spend too much time. We can definitely answer this and talk about it at the end. But one of the advantage is the moment you mark this as tool with the tool decorator, and while creating the agent, if you set this as my tool, you are actually, in this case, telling the model, which is running in the cloud, when to use it and when not to use it. So this is just a plug-in mechanism for the model to know. Say, for example, if I ask my model what is the current temperature of Las Vegas right now, model needs a weather tool. So somehow you need to plug this weather tool to let model know, hey, you can use this tool. to find the current temperature. So this is one way to tell the model you can use it.
So if you have your code, I don't know, whatever you have, and you want to use that code as a tool inside the Strands agent framework, you only have to use the decorator, the arroba decorator tool inside your code. So that's the way that the agent understands that that code, that function is a tool. So if you have the MATLAB, I don't know, whatever function, if you put that decorator right there, the agent is going to understand that that code there, it's a tool that you can invoke later. That's a tool. It's okay.
So I think that maybe what we can do, just for the interest of the time, let's move on. We can follow up after this.
But we are going to be here all the week. So if you have more questions, we can answer that question too. Not only today.
Okay, just to continue the discussion. So far, all the tools that this agent is using, they are actually running locally in the same process as the agent code. Now, what will happen if you have a tool which is running in a remote process, or maybe in a remote server, somewhere in the cloud as a service? This is where we need MCP tools. MCP is an open standard model context protocol that enables the agent to communicate or access a remote service and data without requiring a custom integration for each one. Now, we usually use standard I/O as the protocol to communicate to a MCP tools, which is running locally, and streamable HTTP to communicate to a MCP tool, which is running remotely. With that, let's see MCP tool in action. Now, before I show you the MCP tool, just one comment. MCP tool has two components. One, MCP server, which basically connects to a remote service and exposes the function as tool. Then you have the MCP client, which is actually sitting on the agent side to communicate to the MCP server using the model context protocol. So let's start with the MCP server. So here, I have a Python file where I have three functions: calculator function, which we have seen; analyze video function, which can analyze. It is just a Python code to analyze a video function. And then I have another function called get the current time. Now, to convert this into an MCP server, first thing I need to do is I'm going to import the first MCP from the MCP SDK. Then I'm going to create an instance of the MCP class from the first MCP. Then I want to expose this function as MCP tool in this case, not like a regular tool, MCP tool. So all I need to do is I need to apply the MCP tool decorator, in this case, from the MCP open source SDK. Similarly, I'm going to apply the MCP decorator for this function as well for this function. Now, once I apply this, now I need to start this MCP server. To do that, I'm going to now use the MCP class. But please note, here I'm telling the MCP server to run as streamable HTTP as the underlying communication protocol so that I can run my MCP server in a remote process or in a remote server. Now, once this is done, this is a simple Python file. I can come to my command prompt, and I can run this file using the Python command. If I do that, one second. Let me just see if, okay, I know what's the problem, so let me just fix this. So we're going to start this MCP server. since I have two versions of this code, one where we had the issue, so I had to just apply everything here just in order to start the MCP server, so just 30 seconds. Again, I'm just repeating, which is a good thing, that I'm going to create. I'm going to apply the decorator. Then apply over here for the video function. Then going to start the MCP server with the HTTP as the protocol. Now if I go and run, my MCP server is up and running, and this is the location of the MCP server. Now, once I have the MCP server, now the next thing that we need to do is we need to set the MCP client. For that, if I go to the third notebook, you should be able to see that this is where I'm creating an instance of the MCP client, and I'm using the Strands SDK MCP client class. Now, while creating this MCP client, I'm just telling that this is the location of the MCP server, and this is the underlying protocol to use, which is streamable HTTP. Once I do that, my MCP client is ready. Now, when I'm creating my agent, instead of passing tool function names as the tool parameter, I'm just passing the MCP client as tools here. Internally, MCP client is going to talk to the MCP server, which is running remotely, find all the function names that expose as tools, and set it up for this agent. Now, once I do that, now I have an example, since I'm using 3 tools. So this is an example where I'm asking this agent to analyze the video that we have just seen, scene by scene, provide me the time of the analysis. Then within this video, again, let me replay the video. Just want to make sure. If you see any content in the video that has some risk, compute the associated risk, and then take all the risk and compute an overall risk. So when it is done, you see that it provided the analysis time. Then it's providing all the different elements in the video that has a risk score between 0 to 100. And then it provided me the overall risk score. So that's MCP. So now before we switch, I can take also another questions here on MCP or tool or anything that we have covered so far. I think someone over there had a question. Okay, please.
So let's say I have the ability to execute my agent and tool on the same piece of infrastructure, right? So I don't actually need to create an MCP server, but there are 2 options, right? I can expose tools via MCP, and I can expose tools directly. What are the considerations which would help me determine what is the right approach for me? Like, what could be the things which we should keep in mind while deciding between this choice?
Okay, so this is what is the recommendations. If you have a tool that you know which is going to run in your local process, say inside your same agent code, you don't need to create MCP because MCP is a protocol. It does has its own overheads. So in that case, it is recommended to use the local tools. Now, one of the advantage of creating MCP tool is if you create a tool as an MCP tool and you package it up, today you can run it in your local process. Tomorrow, for whatever reason, you want to put it to a different machines and want to run it as a remote tool, then you can also use that. Then MCP also gives a lot of other primitives. For example, when it comes to state management, identity management, and many other things which does MCP cover. So if you are using the remote communications between the agent and the tool, it is recommended to use the MCP tool. Beyond that, there are many other things we can definitely discuss. So I would suggest either we can take that again at the end, or we can have an offline chat. Now, so far we have talked about Strand agent. We have talked about how agent is using a tool which is running locally, and then how agent is using a tool which is running remotely. Now let's talk about session and important AI primitives. And for that, I will hand it over to Elizabeth.
Thanks. Well, thank you. With the Strands agents, we have several ways to maintain the conversation between each invocation, between sessions. I'm going to start with the second one. We have the agent state. With the agent state, you can have a stateful information outside the conversation, and you can maintain across multiple requests. For example, every time that you send a request to the agent, you can store the amount of when you invoke a tool, specific tools. So you can have that information inside your agent. So that's the agent state. Then we have the request state. The request state is the name, yeah. That request state is the contextual information maintained with a single request. So you can initialize some variables, some information every time that you initialize the agent, because this is a loop, and you can put some information right there. So for the agent state and for the request state, you can always put some custom information right there, like, I don't know, prefill some agent state or prefill some request state. But in this session, we are going to cover the conversation history, because that's the title of the session, probably, with multimodal agents. Conversation history is every time that I invoke the agent, I send a history with the conversation that I maintain with this agent. For example, I say, hello, agent, my name is Elizabeth. The agent takes, okay, hello, Elizabeth. Then when I ask, what is my name? The agent is going to remember my name because it has the conversation history. That's the conversation history. Each interaction is interaction with the agent. So that's the context that the agent has for the conversation that it has with me. And let me show you this in the code. I know that I have. Thank you. Now, in this Jupyter notebook, this is the backup Jupyter notebook, I have the same agent that Joe just showed you. I have a multimodal agent with image reader, file reader, and a video reader local. In this, I don't know if you already saw the repo. In the repo, you have two tools that you can use to invoke the video tool. You have a video reader local, and you have another one with the name video reader. Let me start with this, because I think it's important to continue the session. So if you go there, you have the two tools. These tools are custom tools. I create this tool using the Amazon Bedrock with the Nova model. So that's why this multimodal agent is capable to understand video, because we have a built-in tools inside the code. So because this tool is in the same folder, I can invoke the tools when I invoke the agent, so the agent can understand that. So you have two tools, because this tool that with the name video reader, it uses a S3 bucket to save the video and then do the get. But for this demo, it's easy to use the video reader local, this one here, because it takes the video locally. It doesn't have to put the video inside the bucket, the S3 bucket. And you can see here that we are using the tool decorator inside this application here. So when I invoke the agent, I lose my agent here. When I invoke the agent, because the agent is here. When I invoke the agent, I say, hey, from video reader local, import the video reader local. So the agent knows that this tool is here, so it can take the tool there. So that's something that is good to understand, because for the S3 vector memory application, we do the same. So let's run this. Come on. Let's return to the chat history part. So here, I have this conversation. Hey, you are a multimodal assistant, blah, blah, blah. You already know that. So let's continue. Here in the backup notebook, I have two conversations, so the model is capable to remember the conversation that we have before. So analyze this image, data sample, blah, blah, blah. And this is the same image that Joey showed you here. And when I ask if they remember, it's going to answer me. Let me see, I lost my second question. Here, I will list all the AWS service show in the architecture diagram. I think this is the first one. Let me see if I can run the Jupyter Notebook because I prefer to fail in life. Wait, it's not. I lose another Kiro one. Joey, can you help me?
Yes, sure.
Oh, this one. Thank you.
Let me take you to this. So this is your notebook.
Perfect. Thank you. So I'm going to run this. And something important in the repository that you have, the model provider that you are going to use it the first time is one with the name like this. US, Anthropic, blah, blah, blah. If you have a problem with the model when you run the Jupyter Notebook, you must go to the documentation because in some regions, this is not the model provider that works. Yeah, sometimes you have to use the use. Right now, I don't remember what is the problem with the region, but right now, this region, US West 2, is working with this model. Okay, so if you have a problem, please go to the model ID documentation, and you can change the model ID. So I already run this. So then let's see the multimodal. Hey, are you going to lose this 3-vector database part? Because he left the room, but it's okay. And okay. The model here, in the first question, I say, okay, I'm going to use the image reader tool, blah, blah, blah. So it's going to analyze the image here because I asked him that, please analyze the image, blah, blah, blah. So let's see. So it's going to remember the second one. And everything here is happening. This conversation history is happening here because the agent is here in the Jupyter Notebook. But what happened when I initialize this agent again? The agent is going to forget all the conversation here because I don't have any more session here in this Jupyter Notebook. So for that, we have the conversation manager. And with this solution, we can save the, I went to another part. This is something that you can use, the conversation manager, With the conversation manager, you can save the only one part for the conversation because sometimes we have problems with the content window for the model. Sometimes we don't want all the conversation because we don't need it. So Strands agent allow us to save only one part of the conversation. So here you can use window size of 10. When I say 10, it's not only the user when the user asks. I save when the user asks and when the agent responds me. So I save the conversation by pairs. So I save 10 pairs of the conversation, user and agent. And that's it. I can set a content window that I choose for this conversation. So when the agent starts the 11-pair conversation, I lose the first one below. Yeah. So let's run this. And yeah, because this is when I initialize the agent. And I'm not going to run this. I want to show you the answer because this takes so long. And we have only 20 minutes. So you can test, you can run this, and you can test when the agent is saving only the 10 pairs of the conversation. And it's super cool. Then when you have the conversation manager, you can save a summarization too, because sometimes we want only the summarization for my conversation. So in this case, I'm using a summary radio for 30%. So the agent is going to summarize the 30% of my conversation, and it's going to keep always 5 of the most recent messages. This is, you can use this because this conversation manager, it allows you, for example, if you create an agent without a system prompt, you can create a system prompt, a new system prompt, using the conversation history. I don't know what use case you can use for that, but you can save a summarization in the system prompt for the agents. So the agent, each time that you initialize this agent, the agent is going to have that conversation as system prompt in there. And this is the fun part, session management. So with session management, you can save all the conversation in a folder. So you can have the conversation there, because when we create a Strands agent have a custom chat history. You don't have to do anything. You saw that I didn't do anything, because I start the conversation, I send a request, the agent answered me, I answer again, and the agent remembered me, and I didn't do anything. But if I lost the agent, I lost the conversation. So to save each session for this agent, I can use the file session manager tool. It's not tool, it's inside the framework. So for this, I have a session ID and a storage directory. This is locally. So when I run this, I'm going to save the sessions in my computer, in the Joyce computer. So I save that. And when I run this, for example, it creates me a folder with the name session. And, well, because we run this Jupyter Notebook a lot of times, I have 1, 2, 3, 4 agents here. So each folder is a different agent. So I have this. So I have the session ID, multimodal user session. This is the just I create. And I have the message, because we bought this agent a lot of time. So in each sessions, I'm going to have the user request and the agent answer and everything. But this is locally. And in this case, you have to, let me see. So this is the interaction with the notebook. We can see when the agent saves the information here. And this is not only for a single agent, because you can have a multi-agent session too. So in this, for when you use a multi-agent session, so when you create a session with a Strands agent, you can share the sessions between the agents when you are using a multi-agent application. So the next agent, it can remember the conversation for the agent before, agent after. So the conversation is passes through the agents. I hope you get it. And because this is locally, you can have, I'm going to keep this because we have a few times, and the most important thing here is the vector store. And you can save the conversation, the session conversation in S3 Session Manager too. So you only have to change, let me see, because here. To save the conversation sessions in S3 bucket, you only have to do this. Instead to import the file system manager, you import the S3 Session Manager. You put your session ID, your bucket name, your prefix, and you bought all 3 sessions and the region name. That's it. So if you have an agent a Strands agent in your application, whatever you want, and you put this data, if you invoke this in your agent, you can save every session in S3 bucket. And yes, this is only about session. If you see here, let me see. If you see here, we have sessions and you have the name of the agents, only the name of the agent. If I invoke the agents and then I change the name for the folder where I save the sessions, it's there. I can have a lot of sessions there. But what happens if I want to save the conversation for my users? I want a folder with all the sessions that I have for my user. You can have that too. If you put the session directory with the name of your user, you can have that. But what happens if I want an agent capable to manage conversation that can remember but the preference for my user? You can do that with this, because the agent is going to keep only the session. It's not going to do some recommendation model for you. It's not going to have the conversation and then create some recommendation for the user. The agent doesn't going to remember the user preference. And for that, Agent Core have two options. I just keep all these slides. So I'm going to go to the slide that's matter. Sorry. Wait, I get so far. This one. No, this one no. Come on.
You can use the clicker.
Yes, I can use the click. So, Strands agent have two ways to keep the user ID, chat history. We have managed service as Amazon Bedrock Agent Core Memory. That is amazing. So you only have to invoke the Amazon Agent Core Memory inside your Strands agent. You can do some configuration, and each time you have all your user ID sessions inside the Agent Core, and Agent Core have long-term memory, short-term memory, and it have some ways to build some built-in tools to remember the preference for your user. But we know how to create tools. We know how to create MCP because Joey just told us that. So you can create your custom solution, and this talk is about create custom solution using Amazon S3 Vector Store. And yes, Amazon S3 Vector Store is a capability that we have with S3. We launched this as a preview in July, but yesterday Amazon S3 Vector Store is in GA. So now you have to pay. And yes, I think this is amazing because one of my favorite services, I think, for a lot of people is Amazon S3. And right now, you can use Amazon S3 as a vector store. This is something new because S3 is cheap, and you have everything that S3 have in a vector store. But it have a but, because if you want an application that doesn't have delay, probably S3 vector store is not your best option. Probably you need to think in Agent Core or OpenSearch. It depends of your, of your needs. So let's see what we have today. In this demo that you are going to see, we have the chat history. We send the chat history for a large language model, and we create the context. We say to the model, I need the context for this conversation, so the model is doing like a intelligent summarization. It gives me the most important thing for this conversation with the user and the agent. Then I send that to a large language model. In this case, I'm using BOBA. And this embedding is sending to vector database store. This is my alarm to pick up my daughter, sorry. And you send that to your Amazon S3 vector store. And that's it. That's it that you did. Yesterday, we say that right now, you can use around 50 metadata with S3 vector store. In this application, I am using the metadata for S3 vector store to keep the user ID. So that's the way my agent can know, that's the way that the agent knows where is the user ID information. So let's see the code. Can you keep it? Thank you. We have 9 minutes, so I'm going to give the question when I finish, okay? So let's see the code. This is one. Okay, this is the application. We need the vector bucket name. We need the vector index because this is a vector store. And when we create a vector store, we create an index for this embedding. And we need the embedding model. This application, these tools, because this is a tool. Let me show you the tool. It's this one. When we create a tool, we need to put a context because the agent needs to understand what's the capability for this tool. So this is the capability for this tool. And when after that I create this tool, I learn. So I'm going to share with you some information that I think is important. I learned that when we create tools, the agents doesn't matter the name of the service. So I'm going to update this code because I say S3 vector memory tool for Strands agent. Yeah, this is and this information is in the side of the tool. The agent doesn't matter. That doesn't matter that this tool is using S3 vector store. The agent only need to know that this is a tool capable to save my chat history. Because when I say the name of the service, the agent or the LLM is going first, what is S3 vector store? Okay, S3 vector store is a service, blah, 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 blah. Agent doesn't care about that. Agent only need to understand what are the capability of the tool. Okay, so I'm going to change this because this is not a good practice. Okay, so this is the tool, and this is the part that I say that it's not a good practice. Okay, so why I know this is a tool? Because I have the tool decorator. So here the agent is going to understand that this is the tool. This is all the things. The agent needs the user ID. And when this is a lot of information that here. When every time that the first time that you invoke this tool, the tool is going to search if we have a bucket with a name, with the name of the bucket what we put there. Because if the agent, if we don't have the bucket, it's going to create the bucket. So please be sure when you run this code that the name that you put there is unique. Because to create a bucket in S3 vector is in S3 bucket, you need a unique name. So you can see the code by yourself. So let's run this. I'm going to run this part of the code because I have a nice application just right here, and you have a call. You can join the call. and here. I'm going to run this. I know that is already wrong. I'm going to close this. And let's see. Here, I have a travel assistant. This travel assistant is capable to create He has persistent memory, and it delivered me personalized recommendation. And for this personalized recommendation, first I need to say what are my testing, where I want to go, where I like to see. So I run to this, and it can give me recommendation. If I send an image, I say I want to travel to this place. So the agent is capable to understand the image, it gives me recommendation based on the image. I can send a video, I can send a PDF, I can say whatever we want that you show in the last Jupyter Notebook. So let's run this. We have the agent, the travel assistant. So I'm going to send in my preference. So I am planning my next trip. I wanted to share my travel preference with you. That's my preference. So the agent, and I send the user ID because the agent needs my user ID to save my information inside the S3 vector store. So this is my answer. Because in the tools, I put in there that I need the bucket or whatever. Here, session 2, analyze destination photo. I'm going to send some photo that we have here. Here, we are output. I'm missing my output folder. Here. Yeah, okay. Let me see. Let me show you here, please. So I have this nice video from Barcelona, 6 seconds video. It's nice. And let's continue here. So I'm going to ini. So I will send an image. I didn't show you the image. So first tool is vector database. Porque the agent, I send them the same user ID, so the agent is going to search for my preference, and it's going to recommend some things in Barcelona, Spain. And I'm from Venezuela, I am not from Spain. And yeah, there is all the recommendation that it gives me. Let me see if in some way, yeah, the Sagrada Familia is a magnificent example, blah, 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 blah. And we have the next session. If this command here is to clear the conversation history. So when I send this command just right here, the agent is, this agent here in this Jupyter notebook is going to forget me, but if I send the same session ID, the agent is going to remember me. So I'm going to run this. So I clear the sessions. Now I'm going to send the same user ID with another document. And yeah, the agent remember me. And I can set, oh my God, we have 2 minutes. Okay. And boom, here's all the code that you can use. And yeah, I'm going to keep one question. And the other question, I will keep it when the session finishes. Did you enjoy the session?
How large have you been able to test with the memory? Because like you're showing examples of trimming it
Like 10. I don't remember. Do you remember, Joey, what is the biggest number for the content window that we can use for the chat memory, the chat history?
I think it's 200 MB. That's what, if I remember correctly, but we can check it.
It's in the documentation. I don't know if the Strands agent documentation is super complete. I love it. You can go there, but if you want, we can search it together in a while.
I think the limit is based on the model provider and the model that you are using. It's not based on the agent. Agent is just the framework. So if you use, say, GPT-4 versus Anthropic model, it can vary. So it depends on what the model provider supports.
Well, that would be like a token window of honesty,
Yeah.
along the lines of, because I've been messing around with this a lot, you get to the point where without all kinds of fancy algorithms that people are trying to think of, the idea that the memory starts overwhelming the current chat that you ask. And like your question you just asked is 200 tokens, but the memory is now 100
Yeah.
100,000.
Okay,
And
okay,
how
okay.
The
Okay.
algorithms of how to make that work, because otherwise all you're really getting is slightly better short-term memory. You know, long-term memory is I talk to it now, and I talk to it 7 months from now, and it still remembers.
Yes.
Which is,
So usually the short-term memory, I think the number of days, I think it's like 8 days limit. So if you go to the agent code documentation,
Question is about Agent Core or about Strands agent tools?
well, agent code, yes, but even beyond that, the capabilities, I mean, you guys mess with it on a daily basis.
Yep, this tool for S3 buckets, you know, you manage the tool, you save your information there, it can last forever. But if you are using Agent Core for short-term memory, the memory lasts 15 minutes if the conversation is long 15 minutes. But if your conversation is long 8 hours, the short-term memory is going to last 8 hours for short-term memory. But if you are using long-term memory, that's another conversation because you save the conversation in the vector store, and the conversation is going to be there. That's with Agent Core memory.